Okay. Some of this stuff you're definitely going to know what it is. Some of this stuff I'm going to help you out with. So in number 1, it says sodium chloride and lead 2 nitrate. I'll explain what this is here in just a minute. React to form lead 2 chloride and sodium nitrate. All right. So you should know what some of these things are, and then I'm going to help you out with the rest. So you should know what sodium chloride is. What is sodium chloride? It is salt, but what's the formula for it? NaCl. Okay. Sodium's a positive 1 charge, chlorine's a negative 1 charge. You can't remember, or you can't forget, what you're doing whenever you write a formula for an ionic compound. You got to crisscross your charges. Okay, so sodium's positive 1, chlorine's negative 1. So that's just going to be NaCl. Now, I'm going to help you a little bit with this next part. So there's a couple of things that we don't necessarily go like full blown into in here. And that would be transition metals. Okay. Lead, all right, is not a transition metal. However, it kind of behaves like a transition metal in a lot of cases. So lead is an element that can have more than 1 charge. Sometimes lead will be a positive 2 charge, meaning it loses 2 electrons. Sometimes it'll be a positive 4 charge, meaning that it loses 4 electrons, okay? If you see a Roman numeral like this, you guys know what Roman numerals are? Okay? So if you see a Roman numeral like this right here, that is telling you what the charge is on the metal. So lead is what charge here? Positive 2. Okay, because metals are always positive, and in this case it's positive 2. So I'm going to write your Roman numerals up here up to 6, because you could potentially see Roman numerals up to 6. So you got 1, 2, 3, 4, 5, and 6. Okay, so those are your first 6 Roman numerals. You really won't have to know anything higher than that. All right, so that being said, you have lead, and you know that this lead is a positive 2 charge. Now, nitrate is another thing that we have not talked about. So nitrate is a polyatomic ion. Okay, polyatomic ion. Now, what does the prefix poly mean? More than one. Okay, so polyatomic means more than 1 atom. So polyatomic ion is an ion that has more than 1 atom in it. So nitrate is NO3, and it's a negative 1 charge. Okay? Now, here's the thing. If this is a negative 1 charge and this is a positive 2 charge, that means we need 2 of these. In a polyatomic ion, when you need more than 1 of them, you got to put it in parentheses and then put however many you need outside the parentheses. So when we crisscross the charge, nitrate's going to get the 2, lead's going to get the 1. All right? Now, I would not expect you to do these on your own, so I wouldn't test you over polyatomic ions, but we will do some examples together. All right. Okay, now over on this side, you have lead 2 chloride. So what's lead? It's Pb, and it's a positive 2 charge. What's the charge on the chloride ion? No. Negative 1. It's the same over here as it is over here. So it's negative 1 over here. It's still negative 1 over here. So lead 2 chloride, when we crisscross the numbers, is going to be PbCl what? 2, because you need 2 chloride ions to be able to balance that out. All right, and then last part of this You got sodium nitrate. All right, what's sodium? Na. What's the charge on it? +1. And what's nitrate? NO3. Oh, got a little spider going on right there. And then, what's the charge on nitrate? Not -3. Nope. What was it over here? -1, so it's still -1. Okay, I'm giving you these charges. I'm not expecting you to know these, okay? So sodium I would expect you to know. I would expect you to recognize lead because it says lead 2, but I'm not going to make you know the polyatomic ions, okay? So that's why I'm giving those to you. All right, so that is our equation. Now this is something called a skeleton equation because we have written what's actually going into it, but we haven't actually listed the balanced equation. We haven't balanced it. So it's called a skeleton equation. It's like the bare bones of it, okay? So we need to list this out. Now you may not have room right underneath the arrow to list this out. So I'm actually going to list these over here. So I have sodium, chlorine, lead, and I'm going to keep the nitrate together. All right. Now, how many sodiums do I have on the left? Just one. How many do I have on the right? Still just one. How many chlorines do I have on the left? Just one. How many chlorines do I have on the right? 2. How many leads do I have on the left? Just one. How many leads do I have on the right? Just one. How many chlorines do I have on the left? Just one. How many do I have on the, nitrate. Yeah, I looked at the wrong thing. How many nitrates do I have on the left? 2. Look, see how there's a 2 outside the parenthesis? That means I have 2 nitrates.
You don't multiply the 3 there.
Right. So this is like math. If you have a number outside of parentheses, it applies to everything inside the parentheses. So if I was asking you how many atoms, say, of nitrogen we had, that'd be 2 atoms of nitrogen. If I asked you how many oxygen atoms you have, it's 2 times 3, which is 6. Does everybody understand that? It's 2 nitrate ions. So 2 NO3 ions, okay? So put a 2 right there. And then on the right side of this equation, how many nitrates do I have? Just 1. Okay? All right, this one's actually pretty simple to balance. So if I have 2 chlorines here, what do I need right here? Put a 2. That'll give me 2 chlorines on the left. And it'll also change my sodiums to 2. And now I have 2 sodiums on the left, but 1 sodium on the right. What do I need to put right here? 2. That changes sodium to 2. It also changes my nitrate to 2. So that balances everything out. All right, everybody with me so far? Okay, go ahead and look at the second one. All right, this one's not quite as difficult. Actually, I think you can do the second one. I'm gonna leave that one. Actually, skip down to the third one. All right, number 3, you have barium reacting with water to produce barium hydroxide and hydrogen. Okay? What is barium? Ba. And what's water? H2O. Okay? So you got barium reacting with water, and it's producing barium hydroxide. Now, barium we said is Ba. What's the charge on the barium? It's a +2. It's in group 2, so it's a +2. Now, hydroxide, this is a polyatomic ion. I'm not expecting you to know this. All right? So this is an OH ion. It's an oxygen hydrogen that travels together. It has a -1 charge. So if barium's +2 and hydroxide's -1, you need 2 of these hydroxides. Everybody understand that? You need the charges to balance out. All right. Now, what's hydrogen? It's not just H. Remember this right here? Remember Brinkelhoff? Remember your 7 diatomic elements that always exist as a pair? Hydrogen, whenever it's by itself, is going to be H2. Okay? H2. So that's kind of a tricky thing because people will see that and they'll be like, oh, it's just hydrogen. Yeah, it is, but it's a pair of hydrogen atoms. So there's a few of these that you'll need to recognize, like hydrogen, chlorine, okay? And there's a couple others down in number 7 that you need to be able to recognize. All right? So make sure that you don't miss that. Okay? All right, now, in balancing this, we have barium. Now, normally you could probably leave your oxygen, hydrogen together for the hydroxide. However, this is not the same on both sides. So you're going to need to split this up into hydrogen and oxygen separately. So we got barium, we got hydrogen, and we got oxygen. All right, how many bariums do I have on the left? Just 1. How many do I have on the right? Just 1. How many hydrogens do I have on the left? 2. How many hydrogens do I have on the right? 4. Here's why. This 2 applies to everything inside the parentheses. So 2 oxygens, 2 hydrogens. So that's 2 hydrogens here plus the 2 hydrogens there. That gives me 4 total on the right side. Everybody see that? Yeah. All right. Now, how many oxygens do I have on the left?
1.
Just 1. And how many do I have on the right? 2. All right. So, those are our tallies. Now, barium's already balanced, so let's move on to the hydrogens. If I have 4 hydrogens on the right, what do I need to put right here? Put a 2, because 2 times 2 will give me 4. And look at this. It gives me 4 hydrogens and 2 oxygens. So that one's balanced just by putting that 2 there. That's all we needed to do. Yeah, we'll do number 4. 4 and 5, and then I'll let you do 2, 6, and 7 on your own. Alright. Okay. Now, number 4. When chlorine gas reacts with methane, carbon tetrachloride and hydrogen chloride are produced. All right. What's chlorine gas? Cl2. Remember, Brinkelhoff, chlorine is diatomic. Now, this says it's chlorine gas. Sometimes whenever you have a physical state that is said in the word equation, you may see a little G next to it, or an S or an L if it's solid or liquid. Okay? Does that make sense? G just stands for gas. All right, so if you see that, that's what that stands for. The G. The G stands for gas. So it says when chlorine gas. So sometimes you might see that as a state symbol to indicate the physical state. All right, so chlorine gas reacts with methane. All right, I'm not expecting you to know what methane is, but that is the common name for carbon tetrahydride, which is CH4. All right, so it says when it reacts with methane, carbon tetrachloride and hydrogen chloride are produced. What is carbon tetrachloride? You should know this one.
CCl4.
Yes. CCl4. Is this covalent or ionic? It is covalent, and you know this because it uses prefixes and because it's a non-metal nonmetal. All right, so carbon tetrachloride and hydrogen chloride. So hydrogen chloride is just HCl. All right, and then I would go ahead and tally everything up. You got chlorine, you got carbon, and you have hydrogen. Okay, how many chlorines do I have on the left? 2. How many do I have on the right? 5? Oh, yeah, I do have 5. You're right. So I have 4 right here, and I have the 1 right here. How many carbons do I have on the left? 1. And how many hydrogens do I have on the right? Okay. How many carbons do I have on the right? Just 1. And how many hydrogens do I have on the left? 4. And hydrogens on the right? Just 1. Okay, so there's our tally. Now, normally I would say balance your chlorines first. However, that could get a little confusing considering you have an odd number on one side and you're not really sure exactly what this is going to end up being. And since you have hydrogen and chlorine together, the hydrogen's out of balance, I would go ahead and balance the hydrogen first in this case. So, if we have 4 hydrogens over here, what do I need to put right there? Put a 4. That's going to give me 4 hydrogens, and it'll give me 4 chlorines here plus the 4 here, which gives me 8 total. All right. Now, that's an even number, and we can work with that. So if I have 8 chlorines on the right, what do I need to put right here? Put a 4. That's going to balance it out. That gives me 8 chlorines on the left-hand side. Okay, so 4, 1, 1, 4. That's going to be your numbers, your coefficients there. All right. Everybody feeling okay about this? Okay. We'll do one more together, and then I'll let you do the rest, okay, on your own. So number 5, when sodium oxide is added to water, sodium hydroxide is produced. So what is sodium oxide? Close. Na2O. Because remember, oxide is -2, sodium is +1. So when you crisscross those numbers, you get Na2O. Everybody understand that? It's an ionic compound. All right, so sodium oxide is added to water. What's water? H2O. And it says sodium hydroxide is produced. Now, what's sodium? Na. Anybody remember what hydroxide is? OH. And it's a -1 charge. So sodium's +1, hydroxide's -1, so that's a 1-to-1 ratio. All right. Again, I would not leave the hydroxide together because it's not the same over here. So we need to split this up into sodium, oxygen, and hydrogen. All right. How many sodiums do I have on the left? 2. How many do I have on the right? 1. How many oxygens do I have on the left? 2, because you got 1 here and 1 here. So 2 total. And how many do I have on the right? Just 1, yeah. How many hydrogens do I have on the left? 2. And how many hydrogens do I have on the right? Just 1. Okay. So this one is really easy because you only have 1 compound over here and everything over here is a 2. So what do I need to put right here? A 2. And if I do that, that gives me 2 sodiums, 2 oxygens, 2 hydrogens, and it is balanced. All right. Now, I'm going to give you a couple of hints here to help you with the rest. So, like right here on number 6 and on number 2, see how it says iron 3 oxide, iron 3 chloride right here? What does that 3 mean? That is the charge on the metal. So iron. That means iron is a +3 charge. So you need that to be able to crisscross the numbers to be able to get the formula. You should be able to figure out what carbon monoxide is, and carbon dioxide, and iron. Now, number 7, iodine crystals. So that means solid iodine. Okay? Reacts with chlorine gas. So you should know what both of those things are to produce iodine trichloride. You should be able to figure out what that is too. Okay? So I'm going to give you 10, 15 minutes or so to try to get those 3 answered and balanced. And if you need help, let us know. What? Iron's Fe. Light's coming on.